So when we think about building AI, we usually think about one thing, right? Scale, just bigger models, more data, more and more computing power. But what if we've been looking in the wrong place this whole time? What if the real secret to intelligence isn't locked away in a data center, but it's all around us, in every living thing?
And that's really the big question we're digging into here, based on some incredible research by Giovanni Pizzullo and Michael Levin. They're basically asking, is this relentless race for scale the only way to go? Or is it just one, maybe narrow lane on a much, much bigger highway? So what's the alternative they're proposing? Well, this chart really lays it all out. On the left, you've got the current game plan. Just brute force it. Scale up these giant neural networks with more data and power. But on the right, you have a totally different philosophy. Instead of brute force, we could tap into the design principles of life itself, a system that's had, billions of years of research and development to figure this stuff out. And that brings us to the core idea. The researchers make a powerful point. Intelligence isn't just about brains. Nope. Nature has been solving incredibly complex problems for eons, way before brains even existed. Think about it. Those strategies for intelligent behavior are baked into biology at every single level. I love this quote from their paper because it says it all. Life has a recipe. It's not just some random, chaotic mess. It's a scalable, repeatable process for building systems that can sense, predict, and act to achieve their goals. A recipe that maybe we could finally start learning from. So that's the million-dollar question, isn't it? If a single cell and a person are both intelligent in their own way, how on earth do you compare them? How do you even begin to measure their capabilities? Well, to tackle that, the paper introduces a really brilliant way of thinking about it. Let's talk about something they call the cognitive light cone. And don't worry, it sounds way more complicated than it is. Just think of it as a really simple but powerful metaphor for how far an organism's intelligence can actually see or reach. So here's the deal. The cognitive light cone is basically the size of the problems a system can solve. It's the horizon of what it cares about. A tiny cone means it's only focused on what's happening right here, right now. But a bigger cone? That means it can plan for the future or even think about things that are totally abstract. And check this out. This shows you exactly how it works. A simple cell has a teeny tiny light cone. It's only sensing the chemicals right next to it. Then you have something more complex, like a squirrel burying a nut for winter. Its cone is bigger, it's planning ahead. And then there's us, with these huge cones that let us work on goals that are years away or things that don't even physically exist, like composing music. So, this is where we get to the really good stuff. If biology's biggest trick is constantly figuring out how to expand this cognitive light cone from a tiny cell to a complex brain, how in the world does it do it? What are the actual ingredients in that secret recipe? Well, the paper boils it all down to 5 fundamental design principles. You can think of these as the core rules that life always follows to build intelligent systems at any scale. Let's break them down. All right, first up, the first ingredient in life's recipe for intelligence. It's called multi-scale autonomy. The best way to think about this is to just think about your own body. Your organs, your tissues, your individual cells, they're all kind of doing their own thing, solving their own little problems. But they also work together for the greater good of the whole system. It's exactly like districts in a city. Each one is competent, but they all cooperate for a larger purpose. Okay, on to the second principle. This one is all about how life actually builds things. This one is self-assemblage. Now, we humans build things top-down, right? Like in a factory. Life does the complete opposite. It builds from the bottom up. Its components, like cells, aren't just passive bricks. They're active little agents. It's kind of like building with smart Legos that know exactly where to go to assemble themselves into something amazing. Okay, halfway home. Principle number 3 gets at the incredible toughness of living things. This is continuous reconstruction. See, a living system is never truly finished. It's in a constant state of repairing and rebuilding itself to deal with whatever the world throws at it. This is how a starfish can regrow a leg. That constant state of flux is absolutely essential for being resilient and adaptive. All right, let's get to number 4. And I gotta say, this one is a bit of a mind bender. It's called physical embodiment, and it's a huge idea. Life doesn't just solve problems with a brain, it solves problems with its body. The actual shape of a bird's wing is already a brilliant solution to the problem of flight. The very physics of our bodies does a ton of the computational heavy lifting for us, basically for free. And that brings us to our final principle, the one that kind of ties all the other ones together. And that's pervasive signaling. All those autonomous parts we talked about, they're in constant communication with each other through a web of signals. This is the magic that allows for both things to happen at once: bottom-up self-organization and top-down control, where the entire organism can guide all the little parts toward one big common goal. So let's bring this all back to AI. Why does any of this matter? Because these 5 principles, autonomy, self-assembly, reconstruction, embodiment, and signaling, they give us a completely new blueprint for building intelligent machines. It's a massive shift in thinking, from programming a static computer to, well, growing an adaptive one. And the end goal here isn't just a slightly better AI. It's a fundamentally new kind of AI, one that's truly autonomous, that can solve problems without us holding its hand. An AI that's resilient, so it can recover from damage just like an animal heals. And an AI that is genuinely creative, able to handle situations it was never, ever trained for. Which leaves us with this one really fascinating thought to end on. For decades, we have been trying to code intelligence, one line at a time. But maybe, just maybe, the real breakthrough won't come from writing better code. Maybe it'll come from creating the right conditions for intelligence to grow itself, just like it has on this planet for billions of years.